Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University, with a joint faculty appointment at Ross University School of Medicine. And once again, what I'm doing, and I've done this in previous audio or video, so I wanted to provide you with another chapter of this book. And so one chapter has been, I've provided you some insights about. What is interesting, though, is to combine some policy along with some of the theory that we have been going through. So here's a summary for policymakers, and summary for policymakers. These are the individuals that drafted this copy, and then introduction. Let's go into the introduction. Tells you exactly what this is going to be, and so pre-industrial levels, again, this is way above, and by 2040 we're going to reach this, and it's way above pre-industrial levels. And so there was a decision made at the 21st conference of parties of the United Nations Framework Convention on Climate Change to adopt the Paris Agreement. So the IPCC accepted the invitation, and then actually provided some insight about the 1.5 degrees Celsius. So understanding global warming 1.5 degrees is mainly due to human activity. Actually, this gives more stark details about how global warming will affect us. Between 2030 and 2052, there will be a lot more increase. So the other one, 2040, is kind of an estimate. So warming from anthropogenic emissions from the pre-industrial period to the present will persist for centuries to millennia, and will continue to cause further long-term changes in the climate system. It can cause sea level rise, can cause associated impacts, but these emissions alone are unlikely to cause global warming of 1.5 degrees Celsius. Climate-related risks for natural and human systems are higher for global warming of 1.5 degrees Celsius. But lower than 2 degrees Celsius. Adaptation mitigation is very important. You saw this figure in another video, but again, cumulative emissions of carbon dioxide and future non-carbon dioxide radioactive forcing determine the probability of limiting warming to 1.5 degrees Celsius. So here are alternative scenarios which can actually stop from this progression. So B, climate models project robust differences in regional climate characteristics between present day and global warming of 1.5 degrees. So between 1.5 and even 2, so these differences include increases in mean temperature, also understanding inhabited regions, heavy precipitation, and the probability of drought precipitation. So the effects are quite alarming. So by 2100 global mean sea level rise is projected to be 0.1 meter lower, and global warming of 1.5 compared to 2. And another important point to make up is carbon dioxide leads to carbonic acid acidifying the oceans and then causing impact with sea animals. You can see the differences in the snails and a lot of a lot of life that live under the ocean. So looking at this, and the sea level also will continue to rise well beyond 2100. So the connectedness that we see between humans and nature are more closely interacted and tied together than ever before. So understanding biodiversity, understanding the need for that, and also this leads to the temperature increase leads to species loss and extinction, and so these are projected to be lower at 1.5 degrees Celsius of global warming compared to 2 degrees Celsius. So the lesson from all of this is that slight changes, very much changes in the minute details, once that happens, global warming gets to be haywire, and that starts to also affect other animals, and then eventually humans. So again, this is where it goes into the ocean that I was telling you about, the acidification of the ocean. What does this affect? Well, health, livelihoods, food security, water supply, human security, and economic growth are all projected to increase with global warming. So you can't discount all of the connected sort of processes and the impact that is felt. All these other ones are important, but I'm going through the highlighted ones. Again, adaptation needs will be lower for global warming of 1.5. So what are the reasons for concern and selected natural, managed, and human systems? Well, unique and threatened systems, extreme weather events, distribution of impacts, global aggregate impacts, and then large-scale singular events. So taking a look at that, so if we take a look at RFC1, and then so 5 reasons for concern illustrates the impacts and risks. So the purple indicates very high risk of severe impacts, risks in the presence of significant irreversibility or the persistence of climate related hazards. And here's the distribution. So the purple indicates very high risks right here. So that purple is that. And then red indicates severe and widespread impacts of risk. And that's most every category. Yellow indicates that impacts risks are detectable. And then white indicates that no impacts are detectable and attributable to climate change. So this is the white portion, and so we have red, purple, and white, and yellow. So white indicates that no impacts are detectable, and this is what I said. Now, this goes into extreme weather patterns, distribution of impacts, global aggregate impacts, and large-scale singular events. So when you have large-scale singular effects, that's not felt as much if you have a lot of weight in here. Now, reasons for concern. The more purple, yellow, red, purple, that's very high. So reasons for concern. When you have 2, then it's not handled as well. But when you get into 3, 4, and 5, there's some resilience, but also here you see some red when there's large-scale singular effects, but not as well. So I hope this makes sense. There's not too many more areas to work on.